Hey guys, welcome back to part 2 of the section on lines. What we did last time was we showed that for any function of the form y of x equals m times x, where m is some fixed number, what we showed is that yes, this is a line, but not only is this a line, when we draw its graph not only is the graph of this function a line, this number m determines the slope of the graph. The way it does this, allow me to demonstrate with an example, again, x, y. The way it does this, if this is the line y equals mx, the way it does this is when, well, for example, when x is equal to 1, we know that y is equal to m. And hence it actually controls the slope in that way, because when we go across by 1 unit in the x direction, we go up by m units in the y direction. So that's how it controls the slope. And we call m the gradient. M is called the gradient. The gradient determines the slope of the line when we draw the function y of x equals mx, when we draw its graph. Okay, so the gradient tells us the slope of the line. Let me do another example real quick, because briefly we said that if we have, say, the function, drawing kind of badly. So this is x, this is y. If we have, say, the function y equals negative 2x, if we have the function y equals negative 2x, well, why does it look like that? Because when x is equal to, say, 1, make that clear, that's a 1. When x is equal to 1, y is equal to negative 2. What that means is that when we go across by 1 in the positive direction, when we increase x by 1, y actually decreases by 2. That means it has a gradient of negative 2, because as x increases by 1, y decreases by 2. Or another way of saying that is y increases by negative 2. That's the same as saying it decreases by 2. Okay, so m is the gradient. If in general, let me draw one more kind of graph, one more example of this. Y, x, I don't know. So this is the line y is equal to mx, so the gradient of this one is m. Suppose here we've got x1, and then the y coordinate must be, of course, m times x1, so m times x1. Suppose now we've also got x2, then the y coordinate must be m times x2. Well, another way we can find the gradient, we can actually find what m is from these 2 points. Another way we can do that is actually to find this distance here and this distance here. And we call this distance the rise and this distance the run. And the gradient m, it turns out, will always be equal to rise divided by run. Let me choose a different color. Getting sick of that yellow. So rise divided by run. Well, how do we calculate the rise? The rise has got to be this distance here, which is going to be this point minus this point. So it's going to be mx2 minus mx1. And we're dividing that by the run, which is this distance here. So it's got to be x2 minus x1. Well, using a bit of year 10 algebra, we can factor out the m on top. We can factor out the m on top. So the top part, the numerator of this fraction, is equal to m times x2 minus x1. And we're still dividing by x2 minus x1. And so now we know that, well, m times x2 minus x1 divided by x2 minus x1 has to just be m, because we can cancel these two out. So we're left with just m, as we expected. And so given any 2 points on your line. Given any 2 points on your line, you can always calculate the gradient by calculating rise and run, and then dividing rise by run. So remember, in general, m is equal to rise divided by run. And you can find the rise and the run using 2 points on the line. Okay, what's up next? What happens next? Well, we've covered a great deal of these linear functions, but there are still a whole lot more of them. In fact, there are infinitely many more of them. What we said at the start was actually linear functions are functions of the form y of x is equal to m times x plus c. Well, what does this c do? What happens when we add on c? It's going to be pretty clear to see with a quick example. So this is the x-axis, this is the y-axis. Now let's draw the graph, I don't know, y equals a half x. So this is the line y equals 1/2 x. Okay, now, well, okay, let's take a, I don't know, this is 1, 0.5. This is 2. And y of 2 is, of course, half times 2, which is 1. Right, so now I want to check out what happens with the function y of x is equal to a half x plus 2 when we draw its graph. Y of x equals 1/2 x plus 2. What's going to happen to that? Well, let's start at 0, 0. Oops. What happens when I put x equals 0 into this function? Well, when x is equal to 0, y is equal to 2. So the point 0, 0 actually gets moved up to the point 0, 2. Similarly, when x is equal to 1, y of x is equal to 2.5, which is the same as 0.5 plus 2. So again, this point has been shifted up. And once more, when we put 2 into the function, into our new function, y of 2, that's going to be 1/2 times 2 plus 2. Well, of course, that's going to be 3. So we're going to be way up here. And again, we've increased by 2. And in fact, for every single point on this line, all we do is move it up by 2. And so our line, which I'll draw in a different color to avoid confusion, our line looks like this. This is y equals, running out of room. This is y equals 1/2 x plus 2. Plus 2. All we've done with the plus 2 is actually move the whole thing up by 2. So every point increases by 2. And so all adding on 2 does is shift the entire line up by 2. Notice also, even though I covered it a bit, that it cuts the y-axis at 2. Our line cuts the y-axis at 2. That's because the point where it cuts the y-axis is when x is equal to 0. And when x is equal to 0, everything's going to disappear except for the c term. So y of 0 is equal to c, because m times 0 is 0. So for that reason, what we call c the y-intercept. And it has the effect of shifting the function y of x equals mx. It has the effect of shifting the function y of x equals mx by c. Now c is positive for our example here. C is equal to 2. That's why we moved up in the positive direction by 2. What happens if c is negative? For example, c equals -1. Well, exactly the same kind of effect except if c equals -1, we will go, we will go down by 1. Everything will decrease by 1, and our line will look like that, where this distance here is 1. Okay, so that's what C does. C is the y-intercept, and it moves the graph up or down depending on whether it's positive or negative. Moves the graph up or down depending on whether it's positive or negative. Okay, that's all for this part. We'll do probably 1 or 2 more parts to this section. For now, take care. Bye-bye. Thanks for watching. See you next time.